Okay, so stating the problem. It says steam enters an adiabatic turbine at 5 megapascals at 6x0 Celsius. That value for me is going to be 650. The x in my ZID is a 5, so 650 Celsius and 80 meters per second, and leaves at 50 kilopascals at 1y0 Celsius. The y for me is going to be a 3, so it's going to leave at 130 Celsius, and it's going to go out at 140 meters per second. If the power of the output of the turbine is 8 megawatts, determine the mass flow rate of the steam following through the turbine and the isentropic efficiency of the turbine, and complete the following table. So we stated the problem. Now we need to indicate the overall starting equation. So we are going to use our energy balance equation. This is the simplified version. We can automatically take out kinetic energy and potential energy, so we don't have to worry about simplifying it. We get this simplified energy balance equation that is going to help us find our mass flow rate. So that is our starting equation. Remember that we are ignoring kinetic energy and potential energy. Now that those were our assumptions for the overall problem. So now that we stated the problem and did the assumptions for what we need to do, now we need to create a TS diagram on screen and indicate the following. So we have our TS diagram. Oh, this is so hard with one hand. TS. We're going to have this flow, where this will be our critical point. We are going from 130 degrees Celsius up to our 650 degrees Celsius. So what is going on? From here, we have that at 130, it is going to come out, and this will be our 50 pascals. And for our 650, we see that it is flowing at 5 megapascals. Now we need to determine our values. So for the t-axis, we have 130 Celsius and we have 650 Celsius. Now we need to locate the state of 2s and 2a. Luckily for us, 2s and 2a, they equal the same. And for that value, we had a 7.39. So at this point, we will have a 7.39 right here.